Okay, today is lesson 4.3b. It's about the scope of inference. Okay, and so this is kind of there's two little details we'll get to in a minute that really are easy to confuse the two. So random selection of individuals allows for inference about the population. So if you have randomly selected the people that are going to participate in the study, then you can only make an inference about the population, or at least you are allowed now to make an inference about the population you chose them from. So if you're at St. Mary's and you randomly select students from St. Mary's, then we are allowed to make an inference about all of the population or all of the students from St. Mary's if the students were randomly selected. This is a subtle difference here, and I added the word treatment. It was not in the book, but it made more sense to me. I think it should help you maybe. So random assignment of individuals to treatment groups. So, so now we're not just talking about randomly selecting students to participate in the study, but we're saying like half of them got the drug, half of them got the placebo, or whatever treatment we're giving in this case. So random assignment to treatment groups allows for inference about cause and effect. Remember, random assignment makes roughly equivalent groups. I want you to think about that when you think of random assignment. We're talking about two treatment groups, right? So when you're randomly assigning, we know there's going to be roughly equivalent groups in those two treatment groups, the real group and the placebo group. And so we can make inference about cause and effect. We can actually say there's cause and effect if that's the case. This is a nice handy dandy chart. I would write it down in your notes. It's saying the same exact thing we just said, just in kind of an organized way, so that if you have done both, right, if you assign them to treatment groups and the individuals were randomly selected, then both things will be true. We can make an inference about the population, we're allowed to do that, and we can make an inference about cause and effect. If neither one of those things are true, they weren't randomly chosen or randomly assigned to groups, you can't make inferences about the population, you can't make inferences about cause and effect. And so that's just a different way of organizing your thoughts there, if that helps you. Okay, so the challenges of establishing causation. This is sometimes, so you have to, not only did you pass the test, again, causation was when you have a random assignment to treatment groups. But in addition, you need to have strong association. So positive, strong association or something like that. It doesn't have to be positive, it could be negative. Association consistent. So, not like for a lot of outliers and things like that, but pretty consistent results. The larger values, this is interesting. So the larger values, now we're getting really technical. The larger values of the explanatory variable are associated with stronger responses. So like those kind of points that have large X values. Alleged cause precedes the effect in time. So, we're studying something in the past here. And the alleged cause is plausible. So is it reasonable, conclusion that you're making? So all those kinds of tests are things that we think about. Those are nuances. These are very nuanced things. It's in other words, the idea here, it is difficult to prove causation. It is not easy to prove causation. So it's not like, we have random assignment causation. Well, you need these other things to be true. These are the nuances of it. It's difficult to prove causation because there's a lot of other variables involved. It has to be consistent. It has to be, strong. Those kinds of things are important. Data ethics is not going to be on your AP exam. It might be on my chapter test. Just a couple of basic principles here. I think they're good for you to know because they're basic. When you have a study, this is just basic stuff here. So all planned studies must be reviewed in advance by the institutional review. So before you even do a study, lots of times these are, they can be multi-million-dollar studies you're doing. Sometimes there's a lot of money at stake. And so they want to be reviewed by this board. So they want to protect the safety and well-being. They're not necessarily saying, is it the best idea or not, but is it safe? Like there were some tests done back in the 50s, 60s, probably that were probably not safe for the people involved. That was kind of a thing that happened sometimes. And so, shocking them or whatever it was that they did, there were some things that was probably well beyond what should have happened. People who participate must give their informed consent before data is collected. So that's an ethics thing. So you want to, sign on the dotted line, say, hey, you're part of this study. We're to collect some data here. You're doing this. Because if they don't know, that's not good. We want them to know. And finally, all data, individual data, must be kept confidential. So if you're in a study, they're not going to, like I was in an eye study, they're not going to say, hey, Jeff McCullough was the placebo group and he did this. Like, no, it's going to be like, I'll probably be a number there, right? So it'll probably be like, patient 5 was in the placebo group. They won't know the actual names of the people who were involved. They're just part of statistical summaries. This is how the placebo group did, this is how this group did, et cetera. When they make the findings public, your name will not be in there. Okay, let's look at a couple examples about the scope of inference. And so, again, I think there's a real random assignment and random selection are two separate things, and you need to be able to get those straight. So I think these two examples might help you with that. That's what I'm hoping. And so I do think this is, confusing part here. So many students insist that they study better when listening to music. A teacher doubts this claim. It's probably me. But it could be true, right? Just because I don't listen to music doesn't mean it doesn't help. And suspects learning that listening to music hurts. And suspects that the teacher's like, I think it hurts, actually. So the teacher selects a random sample of 30 students from the school to participate in the study. Each of the selected students is asked whether he or she studies while listening to music, and then their GPAs at the end of the semester are recorded. Students who listen to music while studying generally had lower GPAs than students who didn't listen to music while studying. What conclusion can we draw from this study? In other words, the scope of the inference. Can we prove cause and effect, or can we make an inference to the population? Those are the two questions. So what kind of selection or random thing would happen here, if any? And so it looks like, let's see. So the teacher selects at random a sample of 30 students. Are these put into treatment groups? Like some people get the placebo, some people don't get a different treatment of some kind? I don't think that's the case. So these were randomly selected students. So we can make an inference about the population, right? So with random selection, we can apply this to the entire population. In this case, all the students at this school. With no random assignment to treatment groups, however, we cannot conclude anything about cause and effect. So we don't know that, listening to music caused them to have lower GPAs. That would be a stretch. You can't say that. But we can say that the students who listen to music while studying at this school have lower GPAs in general than those who do not listen to music. So we don't know why their GPAs are lower, but we know that at this school, we can make that inference for students at this school that that's generally true. This is an example from your book. This happened in North Carolina. The researchers were concerned about the increasing dropout rate at the state's high schools, especially for low-income students. They had, surveys from recent dropouts revealed that many of the students in middle school started losing interest in school. They saw little connection between what they were studying in school and their future plans. Okay, so they came up with this program called Career Start. So this is very typical of what a school system might do. So the researchers recruited 14 middle schools in Forsyth County to participate in the experiment. 7 of the schools determined at random, it's important, use Career Start along with the district's standard curriculum. The other 7 just followed the standard curriculum, so they did not use Career Start. Researchers followed both groups of students for several years, collecting data on the students' attendance, behavior, standardized test scores, level of engagement in school, and whether or not the students graduated from high school. Results. Students at the school that used Career Start generally had significantly better attendance, fewer discipline problems, earned higher test scores, reported greater engagement in their classes, and were more likely to graduate. This is amazing. What conclusions can we draw? So can we draw cause and effect, or just inference about that population, or none of that, right? So what's the scope of inference? So what was done randomly here? It looks like So they said there were 14 schools. 7 of the schools determined at random use Career Start. So that's a treatment of sorts, right? So Career Start is the treatment here. So 7 schools were put in a treatment group randomly. 7 schools were in the placebo group, so to speak. They didn't have any extra treatment to them other than just the standard curriculum. And so they have been randomly assigned to treatment groups. So when that happens, assuming all those nuances are true, strong association, etc., then we can say that there is cause and effect. In other words, this Career Start did cause these changes to happen. However, we cannot say this should be applied to other school systems, right? It's only good for this school system. Because treatment groups were randomly assigned and the results were significant, we can conclude that using Career Start curriculum caused better attendance, fewer discipline problems. So it caused all those things to happen, right? However, these results only apply to schools like those in the study because the schools were not randomly selected from any population. So it only applies to this school district. So if you go to California and say, I'm going to try the Career Start and see if this works. Well, you can try it and do another study, but it doesn't, we don't know if it's going to work. We can't make an inference to all of the United States. So everybody should start using Career Start because it's so great, right? So in that school district, we can say it caused all those good things to happen. So that's how scope of inference works. And so now you've seen an example of both. And do your homework. Again, it's a nuance here between random assignment and randomly selecting an assignment to treatment groups or random selection of participants. So you got to get the nuance and what that means with either case there. Great. That is your lesson for today.